The Gauss method and arithmetic series. As said, the main objective when dealing with an arithmetic series is to find the sum of the first n terms of the corresponding arithmetic progression sequence. We solved such an example in the previous lesson, where the sum of the first 5 terms in an arithmetic progression sequence was considered. However, that was a specific case. If the calculation of this quantity, the sum of the first n terms, is not generalized through a formula, like those used for finding the general term of a sequence, we are not on the right path. Let's try to find a general formula for the sum of the first n terms of an arithmetic series. The first who discovered a formula for this was the famous scientist Gauss when he was just a kid. He was asked to calculate the sum of the first 100 natural numbers, i.e. 1 plus 2 plus 3 plus 98 plus 99 plus 100. Surprisingly, Gauss found this sum in a very short time by using the following procedure. We have the following shown on screen. In this way, Gauss obtained 50 equal sums where each of them is 101. In this way, he calculated the sum of the first 100 natural numbers by multiplying the two numbers, i.e. we have the following shown on screen. Since all the sums are equal to the first term plus the last term, x1 plus xn, Gauss realized that multiplying x1 plus xn by n2, which represents the number of pairs obtained, here we have 50 pairs, as 50 is equal to 1 over 2 of 100, gives the sum of the first n terms of an arithmetic sequence. In this way, we have the following shown on screen. Example 1. Use the Gauss method to find the following sums: a. 3 plus 6 plus 9 plus 147 plus 150. b. 4 plus 8 plus 80 plus 84. Solution 1. A. We have the following shown on screen. Thus, for the part inside the brackets we can write x1 is equal to 1, xn equals 50 and n equals 50. Hence, we have the following shown on screen. B. We have the following shown on screen. Thus, for the part inside the brackets we can write x1 is equal to 1, xn equals 21 and n equals 21. Hence, we have the following shown on screen. We can use the Gauss formula in whatever arithmetic series to fit a specific situation. However, first, we must make some arrangements. For example, to find the following sum 7 plus 11 plus 15 plus 75 plus 79, we do like this: since x1 is equal to 7, xn equals 79 and d equals 4, we have from the previous tutorial, we have the following shown on screen. In the specific case, we have the following shown on screen. Therefore, we obtain for the sum, we have the following shown on screen. Example 2. Calculate the following sum, we have the following shown on screen. Solution 2. We have x1 is equal to 22, xn equals 148 and d equals 7. Moreover, since we have the following shown on screen, we obtain the number of terms n of the given sum by rearranging the expression. We have the following shown on screen. Therefore, using the Gauss formula yields, we have the following shown on screen. That is all for lesson 12.2.2. To continue this tutorial, please watch 12.2.3. an alternative formula for the calculation of S(n) in arithmetic series. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.